Thank you very much for giving me the opportunity to give an update on developments in polyester films for the flexible electronic applications. And I hope to give you an update on these properties we continue to develop, but also how we combine them, integrate them with a use case example with OPV and encapsulation. Yeah, we are a global company with 6 manufacturing sites. We have an R&D center where we do the business development as well in the UK, in Middlesbrough, not too far from here. And yeah, our successes are, sounds a bit hollow this. Okay, all right. Our success or our business is really based on 3 pillars. It's the focus on innovation. We like to collaborate with people to find sustainable solutions. That is where we focus on. And in terms of sustainability, PET is inherently more sustainable than many alternatives because of its lower CO2 footprint. As we recycle almost everything, our own scrap, the waste goes back into a process, so we get a quite high yield there. But we can increase it beyond 100% by using post-consumer waste. For example, PET bottles for PET can go straight in our process, and we therefore get a quite even lower carbon footprint. We are in flexible electronics for quite some time. With many applications. You may wonder why that really is. Well, it's because we have PET is inherently chemically very resistant. That is one of the first things which attracts it, for example, compared to a polycarbonate. But it is also due to our process. It has by actual process with a crystallization stage at the end, that causes it to be mechanically very strong, but also optically very superior properties. And in terms of our process, that's maybe worth having a look at, just at the scale of it, and why we can offer it commercially at a relatively low cost and at great quantities. Its film thickness is from half a micron to 500 micron. The recycle rate, well, as I mentioned, over 100%. At times, and a run rate from 20 to 300 meters a minute, 9 meters wide, so that can go up to 2,100 meters per minute, a square meter per minute. That is a huge amount of film. It is therefore can be available at low cost, but also the downside is that the MOQs can be prohibitive for new developments. For that we have pilot lines though, and we can accommodate that in some sense. But at some point it needs to go to the main line, and that is can be prohibitive at times. Now, one question which is often asked is what is the upper processing temperatures for substrates? Now it's TG, that's the glass weakening point, but it's the temperature at which the substrates start to shrink. And that can be much higher. I mean, we condition our film to get it up to 150 degrees, where a sheet, if you heat it up for 30 minutes, it won't change dimensions, apart from creep or bending it or hygroscopic expansion. You get those dimensional changes, but it won't shrink as a result of the orientation process. PEN is even a bit higher than that. However, there is a side point here. What we learned is that if you sheet to sheet is one thing, but if you go roll to roll processing and you put your film under tension at temperature, then of course you will undo what we just try to avoid, is the shrinkage, and you will stretch the film a little bit. Now that could be a problem with your process, but there are ways around that. And with VTT we investigate that and actually wrote a paper, published it. And if you would like to have some advice to how to optimize your process, please just contact us and we can give you some recommendations which guarantee you a perfectly dimensionally stable substrate. The other thing is that, as the Alpha can tell us, the solders, they coming down in temperature which is deep applied.